All right, so I'm going to start Unit 7 today, which is going to be all about sequences and series. So I kind of mapped it out a little bit. It's a funky type unit because we don't have class on Monday, and then Battle Royale is not this week Friday, but 2 weeks from Friday. So we lose class that day. So we lose two class periods in that time. So right now I'm looking at a formative next week Thursday, okay? And then so you'll get the homework tomorrow. You'll get the week 25 homework tomorrow because I'm in the process of retyping it. I didn't like how it looked. I should have said it. Bless you. I liked how it was, but we don't have that computer. We don't have the license for that computer program anymore. So I can't go back and I can't edit the things that I don't like about it. So I got to retype the whole thing. So I'm in the process of retyping that, and I didn't get it done last night because it was my birthday. I don't want to work on my birthday. So, you know what I mean? So we'll get that to you tomorrow. That will be due next week, Thursday. I know we're kind of off of the Friday, like when we have homework due and stuff like that because of missing Monday and missing the following Friday. Okay, so you'll get the homework tomorrow. It'll be due next week, Thursday. That'll be a formative. Then the following, so then on the 23rd, Friday, you'll get a homework. No, I lied. That one, we won't give you homework that day. You'll get a homework on the 26th, and that will be due on the 29th. It's Thursday the next 3 weeks. Okay? Everything's on a Thursday the next 3 weeks. Okay? For homework. And then it's Thursday, Wednesday, Thursday for tests. Okay? It's all, I got it all here. It's all worked out. I even wrote it down just so that I wouldn't forget it. Because, I'm old now. So I forget things more happily. Okay? All right. So you have seen this stuff before. You did sequences and series when you were in Algebra 2 last year. You did them when you were in Algebra 1 a bunch of years ago. Okay? You've seen this stuff before. I don't know if you did some in geometry or not too, but you've seen this before. So we should be able to relatively go through this stuff somewhat quickly, but at the same time, I still want to give this gravitas because in terms of your NCC final coming up at the end of middle of May. I can't say at the end of May anymore. It's the middle of May. There are like 4 or 5 sequences and series questions on that. Okay? So we definitely need to not go as fast through it as we'd like to, but at the same time still give it its just due. Okay? All right. So whatever you take from this, you can write down. You don't have to write this all down word for word. I'm going to talk a little bit about this kind of a stuff. Hopefully, it brings up some deeply rooted memories that you have inside your brain that you've seen before and that fun stuff. Okay? So a sequence is a function of consecutive integers. Okay? So actually what I should do is I should just go into my highlighter, and let's go into the green highlighter and say a sequence is a function of consecutive integers. We'll say that. And that's important. Okay? Typically, that sequence starts with the first term. What that's saying is when you start your sequence, starts, not stats, not sats. That's what that's saying. And it starts with the first term. Okay? They're called terms. The values are called terms. Okay?
A finite sequence has a limited number of terms. An infinite sequence goes on forever. And the two things that you have to look for, well, today, the one thing that you have to look for is those three things right there. Okay? That says it's an infinite goes to infinity. Those three dots means that it's an infinite sequence, which means that that pattern is going to continue forever and ever and ever and ever and ever and ever and ever and ever. And then a bunch more evers. Okay? A sequence has a rule which you're going to be able to find that rule based off of the sequence. Okay? We have three different kinds of sequences. We have arithmetic sequences, which we are going to start today. Arithmetic sequences, we add, arithmetic add, okay? We add to get the next term. Okay? We also have geometric sequences. Okay? That's where we multiply to get the next term. And then we have infinite geometric series, but that's a series. We'll get to that later on. That's okay? So we have all of that fun stuff. So if this is my rule, that's my rule, and I say write the first four terms of the sequence. That means you're going to tell me what happens or what number I get if n equals 1, because that would be the first term in my sequence. Then you're going to tell me what number I get when n equals 2. Then you're going to tell me what number I get when n equals 3. And when n equals 4. Okay? How are we going to go about doing that? Plug 1 in for n. Okay. Could you put your phone away? Thank you. Would you take your earbud out? Thank you. Okay. All right. So if I'm looking for the first term, then that would be a sub 1, not a1. We're not putting some like make it taste good stuff on top of our steak. Okay? And we're not using a1 the sauce. We're going a sub 1 the first term. That is going to equal 2 times 1 plus 5. 2 times 1 is 2. 2 plus 5 is 7. So my first term is 7. Then I got to find my second term. A sub 2 now would be 2 times 2 plus 5. 2 times 2 is 4. 4 plus 5 is 9. So my second term is 9. I separate my terms with a comma in the end. If I'm giving a list in my sequence, I separate those terms with a comma. Then, third term, 2 times 3 plus 5. 2 times 3 is 6, plus 5 is 11. So my third term is 11. Fourth term, I plug in 4 in for n in my function. Do I put dot, dot, dot after the end? Do I do that? Why not? Because you're just writing the first four. Yep. Just asked for the first four. It didn't ask for the sequence. Yep. Good stuff. Okay. Following that logic, with this function, I want you to find me the 4th, the 9th, and the 32nd term in this new sequence. 4th, 9th, and 32nd. So my 4th term is going to be a sub 4. And that's going to be negative 2 times 4, then plus 4. Negative 2 times 4 is negative 8. Negative 8 plus 4 is negative 4. So I would say that the 4th term, a sub 4, is negative 4. I can't just say negative 4 there, because we are not developing the first 4 terms in the sequence. I have to label my term, what term it is. So a sub 4 there would be the answer. Okay? Then it asks for the 9th term. Now I'm going to plug in for 9 in for n. 9 times negative 2 is negative 18. Negative 18 plus 4 is negative 14. So my 9th term, a sub 9, is negative 14. My 32nd term is going to be a sub 32 is going to be negative 2 times 32 plus 4. Negative 2 times 32 is negative 64, plus 4 is negative 60. So a sub 32 is negative 60. And that would be how I would write those out, because it's not, I don't put commas between them, because it's not the first 3 terms of the sequence. Okay. Where we're going to use sequences, so a sequence is just a list of numbers. That's what a sequence is. Tomorrow, we'll get to a series, okay? And a series, then we're going to take the total number in that. So we could answer this question tomorrow. Okay? If each row is a foot tall, how many bricks would be in the bottom row if the wall is 15 feet tall? We could answer that one today because that's a sequence question. But how many bricks would it take to build the wall? That's a series question, because that's going to be a sum then of the bricks. Okay? So that's typical type problems for this particular unit. Okay? So an arithmetic sequence is a sequence that has a constant difference between consecutive terms, meaning you are going to add something to get the next term. Okay. You're going to add to get the next term. Okay. So looking at those two sequences, are they arithmetic? 3 to 7 is a difference of, or what am I adding to get from 3 to 7? 4. 7 plus 4, 11 plus 4, 15 plus 4, 19. So that one is arithmetic. okay? Because we can find the difference between consecutive terms, and those have to be the same. And those are all plus 4, so yes, it is. What am I adding to 20 to get 15? Negative 5. 15 plus negative 5. 10 plus negative 5. 5. So is that one arithmetic? Yes. Okay? So we're adding still, we're just adding a negative. Okay? So that's the difference for an arithmetic. You look for what you add to get that next term. And what it is that you add, we call the common difference. And we're going to label that D in our problem, or in our rule. It's going to be D. It's kind of like slope. It's kind of like the M in it. Okay? So we're going to call that our common difference. Okay? You tell me which of those 4 are arithmetic and which ones are not. Okay? Tell me which ones are arithmetic. Yay or nay on the first one? Yes. What is my common difference? 10. I'm always adding 10. So yes, that one is arithmetic. Second one. Started by adding 3, right? But then I added 5. So that one is not, because it's not the same. It's got to be the same. Okay? Third one. Here I started by adding negative 9. Then I added positive 18. That's a hard no. Fourth one. I'm adding a negative 12. I'm adding a negative 12. And I'm adding a negative 12. So that's a yes. We are going to make a lot of assumptions based off of the first few terms. We're going to assume that that pattern holds throughout the rest of eternity. Okay? Or the rest of the finite sequence. Okay? So let's talk rules now. Okay? So if I have, let's go with, what color didn't I use? Ooh, they like more. They were going to go hot pink. Come on now. Okay. That right there is our rule. Okay. Any term, or the last term that you're dealing with, is going to be equal to the first term plus n minus 1 times d, where n is the number of terms, or the term number that you are looking for, times the common difference d. Okay. Yeah, I like that. I remembered now that I was going to do that. I forgot to do that yesterday. So we're just move the d to in front of the parentheses. Okay. All right. Handle? Love it. Let's do this. So we want to write a rule for these two. Okay? So if I'm going to write a rule for these two, there's my rule again. Oops, let me change this one now too. Okay? So there's my rule. So I need to know if I'm writing a general rule, I need to know some things. The first thing that I need to know is I need to know my first term. Okay? What in sequence A, what is my first term? 1. So A sub 1 is going to be 1. The second thing that I need to know is I need to know my common difference. In this case, it's 2, because we're going up by 2. Plus 2, plus 2, plus 2. So my common difference D is positive 2. Those are the only two things that you need to know to write the rule. Okay? So now my rule can be A sub n is going to equal my first term, 1, plus my common difference D times n minus 1. If I had to, I would accept that as my rule. But I really like it written out in, if you distribute this 2, if I distribute that 2 and I write it out as A sub n is 2n minus 1. I like that better, but I would still accept that one. But it's just easier to use the simplified version than it is the original.
Is it wrong to be called because it asks to find this
No, it asks you to find the rule first.
and then
So you have to get this part first. Then it went on to say, find the 20th term. So now you can go on, and now using your rule, now you have to find A sub 20. It's a twofer. Okay? You got to find the rule first, then find the 20. What's up?
Is it minus 2?
What do you mean minus 2?
Like put
When you put the 2 in, it's 2n minus 2.
yeah.
But 1 minus 2 is a negative 1. Combined like terms. Okay? You find me the rule and the 20th term for part B, for letter B there. I like negative 4n plus 10. I would also take then we needed to find the 20th term. -4 times 20 is, whoa, that breaks. Is -80 plus 10 is -7. Oops, that brings and a sub 20 is -70. Yes? Okay. Another style of problem that we could have here is we could give you a specific term. And if I gave you a specific term and the common difference, you could find the rule going forward. Okay? So if I know the fact that my sixth term in this sequence is -16, that means then that when I go in to use my rule, n would be equal to 6, and a sub 6 would be -16. So if I'm going into my rule, a sub n is going to be -16. That then is going to equal, I don't know what my first term is. My common difference is 9. Oops, I forgot the plus. And my n value is 6. So I can do that math and figure out what my first term is. Okay. 6 minus 1 is 5. So this would be -16 equals my first term plus 9 times 5. 9 times 5 is 45. If I subtract 45 from both sides, I get -61 is my first term. Using my rule, a sub n would be equal to -61 plus 9 times n minus 1. I would accept that one, but I would actually prefer a sub n equals 9n minus 70. Then it said find the 18th term. Nine times 18 is 162, I believe. Yes. 9 times 8 is 72. So 2 carry the 7. 9 plus 7 is 16. 162. Yes. 162 minus 70 is 92. Yeah. Based off of that, what we just did there, what I'd like you to do now is I would like you to find me the rule and find me the 18th term based off of that. So I got a rule of a sub n is negative 7n plus 81. Yes? Anybody get anything different? Anybody go through anything? Yeah. If that's my rule, I stick in 18 for n. Negative 7 times 18 is negative 126. Plus 81 gives me an 18th term of negative 45. Yes? Good stuff. Okay? That concludes day 1 of arithmetic sequences. Tomorrow we'll talk arithmetic series. We'll get you your homework tomorrow, and yeah,